Okay, this is Unit 6, Lesson 8, Reasoning about Solving Equations, Part 2. And our focus question is, how can you use a hanger diagram to solve equations in the form of P times a quantity x plus Q equals R? So you notice that one looks a little bit different. It has parentheses. So our warm-up says select all the expressions equivalent to 2 times the quantity x plus 3. So one thing we know, if you remember distributive property, it says we can multiply this number here by each of these to get an equivalent expression. So if we take 2 times x, that's going to give us 2 times x plus 2 times 3. Or I could just simply write it as 2x plus 2 times 3 is 6. So let's go down the list here and see if any of these match any of these. So 2 times quantity x plus 3. So here they just removed the little multiplication symbol there. So this one is equivalent. This is the quantity x plus 3 times 2. So the commutative property of multiplication says it doesn't matter what order you multiply in, right? You could take 2 times x plus 3 or x plus 3 times 2. So this is equivalent. This one says 2 times x plus 2 times 3. That's exactly what I have here, 2 times x plus 2 times 3. So that is equivalent. And then we have 2 times x plus 3. Well, here we have 2 times x plus 6, so that is not equivalent. And here we have 2 times x plus 3 again, so that is the same thing, almost the same thing, just has parentheses here. And this one is 2 plus x times 3. So I wonder what that would look like if we use the commutative property and move this 3 over to the other side. So we have 3 times the quantity 2 plus x. And then I use the distributive property here. 3 times 2 is 6. 3 times x is 3x. And the commutative property of addition says I can switch these around also, so I could have 3x plus 6. Does that match 2x plus 6? 3x plus 6 and 2x plus 6 are not equivalent. So that one is not correct either. So correct answers are 1, 2, and 3 for 8.1. Okay, let's look at 8.2. Explain why either of these equations could represent this hanger. So we have 14 is equal to 2 times the quantity x plus 3. Or 14 is equal to 2x plus 6. So let's look at this first one. Here we have our 14, and our 14 is equal to this here. And in our equation, we have a group called x plus 3. And since we're multiplying x plus 3 times 2, that means there's 2 of these. And that's what we have here. We have x plus 3 and an x plus 3. So 2 x plus 3s is equal to 14. 2x plus 3s is equal to 14. So let's look at the other equation and see why that would represent the hanger. 14, here's our 14, is equal to, we know it's equal because it's level. 2 times x plus 6. Well, let's move these around. In fact, let's redraw this side of the hanger. So I'm just going to move the 2 x's up here. So I just moved them up here. And then I have the 3 and the 3 together is 6. So I have 2 x's plus the 6. Okay, part 2 says find the weight of one circle. So find the weight of an x. So if I did the same strategy as I used last time, I would subtract the 3 and the other 3 together, right? Because that equals 6. I would take this 6 away from this side, but then I'd have to take the 6 away from this side too. So 14 minus 6, that would leave me with 8 here. And then I would take that 8 and I would divide it by 2. So that 1x would be equal to 8. Right? This is 4. So 1x is equal to 4. So this side's 4 and this side's 4 for a total of 8 right here. But let's look at it another way. If I leave these in their groups and I say we have 2 x plus 3's, we have an x plus 3 here and an x plus 3 here. If I cut that in half right there, I would have 2 groups, right? This x plus 3 is equal to half of the 14, which is 7. This x plus 3 is half of the 14, which is 7. So let's figure out what one of these x's are. If I take away the 3, and I take away 3 from that 7, that leaves me with 1x is equal to 4. And I could do the same thing here, minus 3. Minus 3. So 1x would be equal to 4. So let's see what the strategies look like with equations. So here are some balanced hangers. Each piece is labeled with its weight. So we have 4 different hangers here. And it says for each diagram, assign one of these equations to each hanger. So I can see that I want one hanger that's equal to 16. So there's one. And that's the only one. So this one must be 2 times the quantity x plus 5 is equal to 16. So if I look up here, I have an x plus 5, right? And I have 2 of them. So I'm going to take this x plus 5 right here and multiply it by 2 to get 2 of them. So this one, I'm looking for something that equals 3,000. Here's one right here, and that's the only one. So this equation must go with here. And it says 3 times the quantity y plus 200. So I have a y plus a 200, and I have 3 of those. 1, 2, 3. So this one is 3 times the quantity of y plus 200 is equal to 3,000. I'm going to move that at the top. Okay, let's look at this one here. 20.8 is equal to something. So I'm looking for a 20.8. And there it is right there. So that must be this one. 20.8 is equal to 4 times the quantity of z plus 1.1. So z plus 1.1, and I have 4 of those. I have 4 of those groups of z plus 1.1. Okay, this one must be this one right here. I'm looking for something that equals 20 thirds. Right here, 20 thirds. So 20 thirds is equal to 2 times the quantity w plus 2 thirds. So number 2 and 3, we're kind of going to do at the same time. Explain how to figure out the weight of a piece labeled with a letter by reasoning about the diagram. And explain how to figure out the weight of a piece labeled with a letter by reasoning about the equation. So we're going to start over here with this one. I'm just going to move it over here for now. And let's see, how do I want to do this? I'll do it this way. So if I were thinking about this diagram, I have x plus 5 and another x plus 5. So that must mean if I cut this into 2 equal pieces of 8 over here, then each of these 8s is going to equal an x plus 5. And how would that look over here? Since I have 2 x plus 5s, I'm going to divide that by 2, right? Because that's what I did. I just divided this side by 2. I divided by 2 to get half of it. So now I end up with just x plus 5 is equal to 16 was also divided by 2 equals 8. Now on my diagram, if I take away 5 here and I take away 5 here, I end up with 3. 1x is equal to 3. So on my equation, if I do that, I'm going to take away 5, take away 5, and I end up with an x being equal to 3. The other way of thinking about this, would be to just separate all this out. I have two x's plus I have 10 plus 10 is also equal to 16. So to get from the equation, this equation to this equation, I'm just using the distributive property. 2 times x is 2x. 2 times 5 is 10. And then I take away the 10 and take away the 10. So I take away 10, take away 10, and this is exactly like the previous lesson. So I end up with 2x is equal to 6. And now since I have 2 x's, I divide that 6 by 2 so that each x is 3. So I divide by 2, x is equal to 3. So that's the same way we did in the previous lesson, in lesson 7. So we're going to focus this lesson on this new way we just found of dividing the groups for the rest of these 3. Okay, let's look at the second one. We have this hanger. We have this equation. 3 times the quantity of y plus 200 is equal to 3,000. So we have 3 groups of y plus 200 equaling 3,000. So I notice I have 3 groups here. So I'm going to take that 3,000 and split it into 3 equal groups and take this hanger and split it into 3 equal groups so that each group, this is going to be 3,000, this is going to be 1,000, 1,000, 1,000 to be a total of 3,000. So how that would look over here, I would take, since I have quantity of y plus 200 3 times, I'm going to divide it by 3 to get just 1 y plus 200. And then over here, I divided this side by 3 also to equal 1,000. So now my equation matches what I have here, one group. One group of y plus 200 is equal to 1,000. So let's just focus on one of these groups. So I take away 200 here, and I take away 200 here, which gives me 800. So I take away 200 from each side, which gives me 1y is equal to 800. Okay, let's look at the next one. So I notice here I have 1, 2, 3, 4 groups of z plus 1.1. So I'm going to split this into 4 equal groups. That group's going to go there. That group is going to go there. That group is going to go there. So one of these groups, when I divide it by 4, if I divide this whole side of the hanger by 4, I end up with just one group. So I'm going to divide this side of the hanger by 4, and I end up with just one group, z plus 1.1. And I take this 20.8 and I divide it into 4 groups, right? 20.8 divided by 4 is 5.2. So this one of these groups is 5.2. So 5.2 is equal to z plus 1.1. So I'm going to take away the 1.1, and I'm going to take away the 1.1 from 5.2. So z is equal to 4.1. Okay, let's take a look at the last one. Fractions. Okay, so I have 2 groups. I'm going to take this side of the hanger and divide it by 2, right? I'm going to divide this into 2 equal groups. So now I have, I'm divide this side by 2. So now I have w plus 2/3 is equal to 20/3 divided by 2. That means each side is 10/3, right? Because 10/3 and another 10/3 gives me 20/3. So this is 10/3 is equal to one group of 2 plus 2/3, or w plus 2/3. So now I'm going to take away the 2/3 from here, and I'm going to take away 2/3 from the 10/3. If I take away 2/3 from 10/3, that's going to leave me with 8/3. So I'm going to take away 2/3, take away 2/3, and I end up with W is equal to 8/3. So let's look at our summary. How can some equations be represented in two different ways? Well, we looked at two different ways, right, using the distributive property. So if we have an equation like this, 4 times the quantity of x plus 7 equals 40. If we use the distributive property, 4 times x is 4x, and then 4 times 7 is 28 equals 40. So we have two different ways of looking at that. And if we make a hanger diagram of this, if we make a hanger diagram of this side, we would have 4 x plus 7s. So we would have an x and a 7, an x and a 7, an x and a 7, an x and a 7. So we have 4 groups x plus 7, and on this side we would have a group of 40. But the same thing over here, if we made a tape diagram or a hanger diagram of this one, we would have this 40 over here again, but it would look a little bit different. We would have 4 x's plus a 28. So here we have our 4 7s, which is equal to 28, and we have our 4 x's, which is equal to 4x. So solving these looks a little bit different too. If we have a quantity being multiplied by a number, we can divide that quantity by that number first. So in this case, 4 times the quantity of x plus 7 is equal to 40. Now we have a new strategy. We can divide by 4. So x plus 7 is equal to 10. So x would be equal to 3. And on this side, same thing. It's the same equation, except we have 4x plus 28 is equal to 40. We subtract 28, oops, that's 40, and subtract 28. So we get 4x is equal to, what is that, 12? And we divide by 4, divide by 4, and we have x is equal to 3. Same thing, 3 plus 7 is 10, 3 times 4 is 12. We get the same answer. So it's really up to you on how you want to solve these. If you see a problem like this and you want to change it, if you want to use the distributive property and change it into this form here, that's totally okay. Or if you're comfortable dividing each side by the number outside the parentheses, that makes it a little more efficient sometimes.